This is the Amp Hour podcast. Released November 7th, 2022. Episode 608. Vapor Phase with Saber Kaygusuz. Welcome to the Amp Hour. I'm Chris Gamble of Contextual Electronics.
And I'm Saber Kaygusuz from PCB Arts. Hi, nice to be here.
Hey, it's good to hear from you. Good to talk to you again. We met in person at I'd seen your stuff online, of course, and we're going to talk about that here. But we met in person at Embedded World. You were in the startup area at Embedded World, and I was walking by, and I was like, "Well, I recognize PCB Arts." So, what were you showing? What are you showing at Embedded World back in June?
Yeah, back in June, we introduced our latest product, EdgeKit. EdgeKit is a modular-based hardware on NVIDIA Jetson. So for other software engineers back there or out there, when you're focused, for example, for some use cases and want to do something with machine vision and something like this, we built a modular hardware that you don't need to introduce or to going to custom engineering, for example, a whole hardware thing at this point. So you could plug it together and starting developing really fast and also going really fast to deployment at this stage. And this was our focus point with EdgeKit. And we meet there.
That's great. Yeah, no, and I think that kind of thing too, where so like the NVIDIA Jetson is like a AI kind of edge processing type of thing, right? And they market it to software engineers, and they're like, yeah, you can get this plug-in board, and it's got a little breakout, and you can use it like a Raspberry Pi. And then everybody goes, okay, how do I use this like in the real world? And they're like, well, you got to go figure that out. It's like, wait, what? that's not cool. So yeah, this is a great idea to have this sort of thing.
Yeah, thanks a lot. Back then we also got really good feedback about this because we learned that I think not that much software engineers want to care about hardware. And this was also why we introduced that, because we are hardware specialists and an engineering company, and this is our focus point. And we want to enable different use cases for machine vision and machine learning out there, because I think it's more than a buzzword. And especially here in Germany, it's got buzzwordy every time if you talk about AI or machine vision or something like this. But to give them a real value and some real use cases, and we want to support the different software engineers out there with our product.
I think and plus like the most interesting applications are going to be this are going to be like in factory in Germany, like watching a robot arm and making sure it's doing the proper thing. And it's like you can't just stick a dev board on the edge of that and be like, oh, it'll survive okay. It needs to have like good enclosure, good heat protection. It needs to just have all the peripherals that it needs. So yeah, I could see all that sort of stuff.
Absolutely.
Yeah. What's actually in? What are some of the modules that plug in?
So right now we support different use cases at this point. For example, if you have opto-isolated IOs in the industry like you're talking about right now, you could talk to other machines with the opto-isolated IOs or with an RS interface. This is also a module which we support right now. And also, customizable relays, for example, default relays to 24-volt DC machines you could turn on, turn off, and everything like this. Yeah, we have media modules. We call them media for camera applications, for example, and industrial module for all industrial applications, but also the normal Jetson support package, I would say. That's our main board, where you could plug in the Jetson Nano, the Jetson NX, and every board, every SOM board from NVIDIA Jetson series right now, to enable different use cases out there.
That's great. And you guys do have a really fun. I'm playing with the configurator of the actual thing too, so that you can put together like, hey, you want to hang this thing on a DIN rail, you want to have this certain case type, you want to have active cooling, you want to all the different plug-in boards, stuff like that. It's nice like 3D modeler and stuff like that too. It's just great. This is really cool.
Yeah, this was also one idea of us, because from our point of view, if you're a software engineer and you don't want to relate with the hardware and have to do something with the hardware at this point, we thought that we could make it, or we should and have to visualize it in the the best way how we could do it. And
Hmm.
yeah, this is with the web configurator you're seeing right now, and also yeah, with WebGL and everything what's new in the web,
Hmm.
we
Yeah.
use there at for the visualization at this point to make it to make a really good customer experience and user experience at the first point out of it. Also
Yeah.
with a live pricing, which isn't common, to be honest, in the market of the edge AI right now.
Right, right. They just say, "Call our salespeople, and of course we'll give you a price." It's like, come on. You know,
Yeah.
my friend recently asked me for uh, a, he asked for a service recommendation, and I started to give him one. He's like, "No, no, no, but I don't. If I have to talk to a salesperson, I don't want to hear about it." It's like, "Oh, okay, yeah, yeah, I get that. Like, I relate to that. You know, to like just wanting to be able to play with all the different options, see what the price is, and like make your own
Mhm.
decision based on that. And then maybe you talk to a sales guy to be like, what about discount, or you know, like all the stuff that the salespeople want to do anyways."
Absolutely, absolutely. I'm also one of the persons who don't want to talk to the sales guys, to be honest, because yeah, I want the live price. I want to discuss it with my team internally, for example, for different solutions, and then going to the sales guy and ask for discount or something like this. Yes, of course, and this is also one point why we choose the live pricing at this point,
Yeah.
because also a lot of software engineers are from smaller startups and everything, and
Hmm.
they could
Yep.
choose their configuration on their own in their room without talking to other people. And
Yeah.
this is also, I think, one common thing all engineers have in common on the earth. They maybe are a little bit more on the introvert side than on the extrovert side.
Hmm.
So
Yeah. Yeah.
yeah, better playing with an online configurator at this point rather than talking to other people.
I feel like that also, like, you know, it like people look at that, they hear you and I say this sort of thing, and they're like, oh well, they just want to, you know, not talk to someone. But I feel like it's also like having these kind of selection things. It's like it's literally it's like a trade-off machine, right? It's like in
Hmm.
this case it's money versus whatever, but it might also be space. It might also be like when I think about other configuration type tools like this in the past too, or like say I'm doing comparisons between different chipsets. What I really want to know is like, okay, I need three UARTs for some reason. That's
Hmm.
fine. I could look at all the parts that are there that have three UARTs. But what I really want to know is what do I have to give up in terms of like pinouts, and I have to give up in terms of, you know, maybe power or other things in there. Like it's not just the does it have it. It's not just the shopping. I'm not looking for a shopping experience. I'm looking for a trade
Yeah.
off experience.
Hmm. And absolutely, and exactly this is what we want to give other people out there, yeah, directly via this web configurator you see right now,
Mhm.
is to, yeah, have this trade-offs by itself or by himself at this point, and yeah, to have also the trade-offs really fast and have all the informations on the desk what he needs to also make decisions at this point.
Yeah.
And this was really important also for us. That's why I think we developed on this configurator you see right now about half a year, to be honest.
Oh
So it's
wow. Wow. Yeah.
completely over engineered, but to have WebGL, yeah,
Yeah. I mean,
don't go
it's
laggy and buggy and everything. Yeah,
uh-huh, yeah, yeah, yeah.
it's
Spinning
really
up
hard.
containers, and it's doing lots of. Is this all running on one of the NVIDIA Jetsons or whatever?
Unfortunately, not at
No,
this
yeah,
point.
yeah.
So
So let's talk about the actual like applications too. So why the Jetson? Why were you looking at that in the first place?
at this point, we decided, I think, 2 years ago, to go with the Jetson because of two main reasons. So the first point was back in 2017. Maybe we came later to that. We had a company. It was, yeah, that's maybe a fuck up story. So we had a company back there where we built robots, and also using NVIDIA Jetson boards within the robots, which
Hmm.
analyzed, yeah, or which had 3D cameras and everything in it. And we had the problem in this earlier company that we don't have any hardware which could be implemented that fast into the robots without much pain.
Hmm. Hmm.
And yeah, we searched a solution back in 2017 for this problem, but we didn't find one. And after we don't make this company anymore, this robot company, because yeah, the business model wasn't that good at this time. We're focusing on helping other engineers in the software area, like for example, we was in this earlier company back then.
Hmm.
And this was the first point because we had the same problem. But the second main point was that NVIDIA has the biggest community for software developers out there for machine vision. And if you have a problem, for example, the CUDA integration or something like this, you know that some person out there also have the same problem or had the same problem. And
Huh.
this problem also was discussed, for example, in online, for example. And this is
Yeah.
why we also choose NVIDIA, because the software community is the biggest and, in my opinion, also the greatest one out there right now.
Yeah. No, that's really smart from like a business perspective too, because you're basically like you're serving a known market. You're part of that market, right? You have bona fides as like people that have been building stuff as well, and that makes a lot of sense. I mean,
Mhm.
people that are developing software on this sort of thing, are they kind of? I'm just kind of curious about the industry there as well. Like, are they embedded inside larger companies that might be like you said, doing robotics and things like that, or are they kind of out on their own, trying to build their own startups and things like that?
So mostly they're smaller companies, to be honest. So right
Mm.
now, I think also in the German big companies, they're more conservative, maybe at this point right now. But the machine vision things aren't in the heads of the people which are
Hmm.
right now in the bigger companies, I would say.
Right. In about 3 years, some brilliant CTO at at Siemens is going to be like, "We've come up with something amazing. It's called machine vision." It's like, okay, okay, buddy, okay.
This is super new. This is super new right now. No, I
That's
think the
right. Yeah.
German industry right now is hanging on IoT. So IoT is
Hmm.
the
Hmm.
greatest big stuff right now in the industry in Germany.
Right. So
No,
new. So new. So hot.
yeah, absolutely, absolutely. And yeah, this is why we're also focusing right now, maybe the smaller companies at this point. There are a lot of startups like we are, for example, which are helping bigger enterprises and companies for integrating machine vision applications. For example,
Mm,
yeah, for the car industry in Germany, they have a
yeah.
light tunnel, and in the light tunnel they could analyze some issues at the car at the end of the process of the manufacturing, for example. And this is also one case which is done right now with cameras and camera analytics to detach scraps or something like this
Hmm.
on the car and on the vehicle before it's going out to the customer. And this is one point where machine vision from startups is implemented into bigger enterprises in Germany right now. So we are mainly talking right now to the smaller companies. Luckily, because we also have faster processes at this point
Yeah. Yeah.
to talking with the customers.
Well, and I mean, big companies come from small companies, right? So you never know in terms of what's going to hit. So that's not a bad thing either. I think you might have people that are you're serving their needs directly, and yeah, I think there's just that's a good way to do it. Especially if you, like I said, if you're going from a community like the Jetson thing. So I
Hmm.
personally I haven't used the Jetson series of boards. I mean, it like runs like Linux on there. What is the
Hmm.
actual what's on the board software wise?
Yeah, on the board is normal Linux with Ubuntu 18.4, and right now Ubuntu. So 18.4 for the older modules, and for the new later and newer modules, they are running Ubuntu 24 on it with the latest Linux kernel. Or yeah, and it's really nice and easy, I would say, to set up. So to be honest, from a machine vision analytics side, we also don't do that much in the systems here. What we are focusing on is to make the hardware to the OS and deliver the finalized OS with all kernel adjustments and everything
Ah,
to our
yeah.
customers, so they don't have to care about if, for example, the camera via CSI is or could be communicating with the application. So this is one point we take care about because we are the kernel specialists here at this point. And also for this mission to enable software engineers to focus on their application and not to anything else at this point. Because
Right, right.
like I said before, back in 2017 we had the same headache and the same problems back there, and we wanted that someone else could solve them for us.
Yeah, right. Do you know how much money I would pay for someone to solve this problem right now? Yeah. No,
Yeah,
that's
this
that's
is
really interesting
mhm.
too, is like so because I think even if you went to say like a software person, you're like, all right, you're going to go learn PCB design. You're going to figure this stuff out. You're going to get all the way through it. Awesome. You did it. You have a thing, you have a card edge connector the Jetson Nano could plug into, and
Hmm.
you have all your peripherals on it. You've tested them and they're working. It's like, all right, now it's time to learn build router Yocto. Ah, so yeah, that what do you guys use for rebuilding a kernel with all the hardware stuff in there?
We could use a lot of frameworks from NVIDIA at this point. So NVIDIA also have documentations for the hardware guys, I would say, and we are working close with NVIDIA at this point, also for building all the hardware kernel modules and everything like this.
So that's part of like their software flow is basically to make it easier to be part of Linux there basically.
Hmm. Yes, of course. And also, for example, for the camera applications or something like this, we are working with camera distributors and camera manufacturers out there to also integrate the different kernel modules and camera modules into the Linux system because they're providing the drivers for us. So we could implement that to also help our software engineer, our hero, our customer at this point, yeah, for realizing their application really fast.
That's great. Yeah, no, that's I mean like that's so much of the hassle of like I think about the people that are doing this sort of thing. Basically, you guys are outsourcing what would happen inside a larger company if they, people were building their own custom hardware. So you're basically kind of that in between step. And I assume some of your customers might end up bringing, if they got big enough, they would be like, oh, we're going to bring this stuff in house at some point. But there's so much, I feel like so much knowledge in a service like what you're doing. That's great.
Yeah, but also at this point, if there are larger companies, for example, like you said, they're doing that in-house, they obviously do that, but they're also focusing on rapid prototyping and yeah, trying to develop their application really fast. And before they have a hardware, this takes around 6 to 8 weeks or something like this, and also a lot of engineering effort at this point. So why don't start with, I would say, a dev kit
Yeah, totally.
with all the possible connectors you want to have in your systems to also integrate, so to be interactive with machines and everything like this. So this is also one point we are maybe helping bigger companies at this point. But as you said, if you're going to production for larger quantities, also, we also wouldn't recommend anymore the edge kit. So we also do
Yeah.
some analytics at this point, and we would say so a custom engineering effort for Jetson Nvidia is around 15 to 25,000 euros for or dollars for bringing the product out. Yeah,
It is pretty much the same thing these days, which is pretty crazy. Yeah. The
yeah.
fact that the
This
dollar and the euro is yeah, it's crazy.
Yeah, one year ago that wasn't so extreme like that. This was
Yeah,
also
yeah.
one point which we learned in the crowd in our crowdfunding campaign for another product. But let's talk
Mhm.
later about that. So
Yeah, yeah, definitely. Yeah. That's yeah, we're definitely gonna get to that, and I probably should have led with that as like a little teaser for what we're gonna talk about. We're gonna leave that in the second half of the show here, which is a vapor phase machine. Yes, people, there you go. There's the teaser. But yeah, that can end up hitting a lot of, business operations type things if, currency starts moving around on you like that. That's kind of problematic for especially if you're
mhm.
trying to like forecast out by 2 years or whatever most crowd supply or crowdfunding campaigns do. So
Yeah, absolutely. That that is really hard.
on the so then the Jetson boards and the modules and the things that you make here. Sorry, I've already forgotten the name. The Edge Kit.
Mhm.
How big is your team that's building this sort of thing? I mean, like, is this small team getting larger team?
So right now we are yeah, a really small team from 6 people, and we have 3 hardware engineers, 2 software engineers, or yeah, one software engineer and the other guy is me. So I have to differentiate that because I'm mostly in the web development, and if I'm saying to other persons who are real software engineers, they say, okay, web development isn't real engineering,
Well,
but
around here, any kind
so,
of code is software. It's outside the software is it's software. So that's we
yeah.
understand that. Yeah.
I'm doing
Uh-huh,
software.
uh-huh,
Okay, I'm
uh-huh.
fine by that. And yeah, one person was mainly focusing for all the business operations, and yeah, doing all the stuff with the taxes and the
Yeah, right,
buy-in stuff
right.
and everything.
Yeah, that's
What keeps us away from being creative?
yeah. Yep. Well, that's good. That's a good sized team in there and stuff like that. So, yeah.
But we're also trying to yeah, become more people, because what PCB arts in the core is, we want to focus on that we want to be a creative place here in Germany, for creative people, for software engineers and hardware and electronics
Yeah.
engineers to come here and yeah, make interesting projects for different customers, but also to creating products for other engineers
Mhm.
out there. That's the core of PCB art. So producing products out there for people, or for engineering people, like for example for software engineers the edge kit, and for yeah, the hardware engineers the vapor phase one oven. This is what's all about, to help people at this point to get a faster innovation cycle. This is the main point. We are focusing on the
Mhm.
products, and the other way is that we are also developing as a normal engineering company products and projects for other for our companies, other customers at this point. And this is how we yeah, working as a team, so on projects and on products, to have also a really good calculation basis and to have a predictable cash
Mhm. Yeah.
income
Yeah.
at this point. Because yeah, if you're doing engineering, you just could do around 3 months of planning, something like this. So custom electronic engineering, for example, because the customers won't wait 6 months or 9 months before you begin
That's
projects
right.
for them.
Yeah.
So yeah, you just have a calculation basis of around 3 months, and this was the main problem how we started at PCB Arts, because we just could take a look into the future within 3 months. At this point, we said, okay, let's focus also on helping other engineers with our products, which also is obviously great for the other people at this point, but also for us, because the income at this point is more calculatable and predictable at this point.
Yeah.
And so we have a good mix out of engineering and products, also because of being more predictable with the money which comes into the company, also which let out of the company.
Right. So are you saying that you're planning 3 months out, or that you won't take engagements that are longer than 3 months because then it's a stretched out timeline?
Yes, normally we're planning with 3 months. So, and what we see that if we are planning for 4 or 5 months with our customers, they want or they didn't work with us at this point, because it takes too
Ah,
long that we
I
start for
see.
a
I
different
see. Okay,
project.
so it's
Mhm.
basically the customer requirements are that like you need to kind of do these fast hits for them in order to hit their requirements.
Mhm. Yes,
Yeah,
absolutely.
that makes sense. Yeah. And then that benefits your business because
Yeah,
fast projects, fast payment, hopefully.
yeah. Hopefully, yeah.
Yeah. I do find it's interesting with like smaller companies too. I'm not sure
Mhm.
how it is in Germany, but like with smaller companies in the US, the payment terms are less stringent. Like they're used, they're not like an old industrial company. My friend works at a defense contractor. He's like, "Look, our subcontractors are on net 90 and they're lucky if they get paid on that timeline."
Okay.
And I'm like, holy crap. I cannot imagine doing work today and getting paid maybe 3 months later. Like the amount of cash you need to have to be able to float. Like maybe you're going to make a ton of cash doing that sort of thing. And that's why these
Mhm.
subcontractors put up with it. But like as an individual, as a one person dev shop, I can't imagine waiting 3 months for a paycheck. Or if I am waiting 3 months, I'm screaming my head off at the end of those 3 months and be like, give me that money.
Wow, that's absolutely crazy. So I also think we wouldn't do something like net 90, to be honest, because like you said, we are also 6 people right now, and mostly all in full time, and we have yeah, big salaries, or not big salaries, but a big salary part that
Yeah,
we have
yeah,
to pay
totally.
monthly, on a
Yeah.
monthly basis. And yeah, we have to pay that, and also the customers have to pay us if we
Mhm.
work for them. It's yeah, easy like
Yeah.
this, I would say from my perspective. But we also had these customers which asked for a net 90,
Mhm.
for example. And to be honest, I said to them, we can't
Right.
do that because that's too late. That's too late. Yeah.
I mean, yeah, I mean, it's like maybe if I was like independently wealthy, but at that point, would I really be doing your design work for you? It's like, oh, I do layout on my yacht. Yes, in the sun
Yeah.
on my 100,000 inch TV, or whatever it is, yeah.
Absolutely. Yeah, absolutely.
Well, that's interesting. I mean, and it is an interesting mix as well from like having products, right? So then basically you are your own internal customer now, where you are developing. You have these configurable products, but I assume that you're building and holding stock of these individual boards, and then you're
Hmm.
assembling them later. So then you basically are one of your own consulting clients, and I imagine that that pull
Yeah.
is difficult.
Hmm. After we started the company back in 2019, we are focused first of all about all the engineering stuff to have a good cash flow and a secure cash flow at this point, but also to reinvest all the money which we earned to equipment we
Oh
needed
yeah,
for different other projects and everything like that. So yeah, equipment is extremely painful for from a business point of view
yeah,
because you just need some
yeah, yeah.
equipment once a year or
You
something
give
like this.
Keysight $20,000, and you're all excited when you get it, and then you use it, and then you're like, "Oh, that's just gonna sit on the shelf, isn't it? Oh my god." You just like look over
Yeah,
every day, and you're like,
yeah,
"Oh, there's twenty
that's
thousand dollars. That's just becoming less money because it amortizes and like, holy crap, or depreciates rather."
so yeah, and why nobody
Yeah,
use it
right.
use it under the year and just
Yep.
once a year.
Yeah.
But
You're talking
yeah,
about a VNA, aren't you? It's the
it's
VNA,
equipment.
right?
Yeah.
That's the painful one. You only have to
Yeah.
do it for FCC.
That's
Yeah,
absolutely
yeah.
painful, yeah. Yeah. One of our things what we bought this year was a climate
Oh
chamber
yeah. Yep.
also. Yeah, it's also incredible heavy because we're at the first floor. We have to put it in the
Uh-huh.
first floor here. It was
Yep.
super heavy, but yeah, it's also extremely expensive, and it's also running I think once a month. So luckily not once a
Uh-huh.
year, but it's
Wait, and when you say
it's
first
good. Yeah.
floor, is this the thing where in Europe the first floor is actually one flight up of stairs? It's not the ground floor; it's the first floor. So that's the is that right? So the
Yeah.
one flight is
Yes.
because in the
So we
U.S.
have
we would we
20
would we
stairs.
would call
Yeah.
that the second floor, but yeah, so like first floor, I was like, oh, that's not that bad, but yeah, that I that's terrible when you have to like get it up the stairs, and if we don't have a freight elevator, it's like, oh man, that's crazy. So
Yeah. It was workout at this day for the whole
exactly,
team.
and a
So
small team means you're not hiring movers; you are the movers. Yeah.
yeah, we are
Yeah.
the
Oh
movers.
wow. Yeah, and that's the other thing too is like I feel like when you're doing, it's always like these it's like surge it's like these surges where you don't need one thermal chamber. You need like three thermal chambers, but you only need them for like a month at a time, and it's just not realistic. And there
Hmm.
are rental services and stuff like that. At least where I was in Chicago, I haven't even looked in the area here, but that's always a premium
Hmm.
for that sort of thing too. And so yeah, it's a tough thing as a business owner.
Yeah, and this was just one of the investments we did in the last time, but there are a lot of different equipment we needed for us. And this equipment we had bought from the first engineering contracts we had back in
Hmm.
2019 then. And yeah, after that we have mostly all the equipment in our lab. Then we thought about it, okay, what we could invest also in or where to put our money to also invest into different things. And one major point were our products at this point.
Yep. Yep.
Like you said before, we are our own clients, and we also needed to care about to have stock, especially for the edge kits right now, and also for the vapor phase ovens, because of also the
Yeah.
shortage.
Right.
So we have to buy in, I think, 1.5 years in advance.
Oh.
So the edge kits we've launched this July on the embedded world, we bought different parts like PCI Express hubs and everything 1.5 years ago,
Wow.
which were delivered I think in
Oh
May
my
this
gosh.
year, and also some chips are already delivered in October I think, so last month. And this was pretty heavy because we have to invest
Yeah.
really a lot
Yeah.
of money for our first batch of 500 modules or 500 EdgeKit
Mhm.
mainboards, which is yeah, sh- which is a little amount of money.
R Right, and you need to get to 500 in order to get the so Matt Liberty was talking about this last week too, right, on the Joule Scope. Basically, you have to get to 500 to get,
Mhm.
price breaks and all that other stuff as well, and it's just like, yeah, it's a huge cash flow tie-up, it's crazy. So, man, my heart goes out to you.
Yeah,
That's tough.
especially for a startup.
Right. That's crazy. Well, hopefully, it's all paying off and you're able to sell these very quickly and start the process to build a bunch of new ones, and by hopefully, on the next build, it's a little easier, a little bit less shortagey than it has been.
Yeah, I also hope so, but let's see how it
Mhm.
works.
Yep. Yeah.
So right now the sales process comes and every of this other product management
Mhm.
things. So I would say if we have our prototype here, for example, from the Edge Kit, we have done this process of developing products the second time. So the first time was the vapor phase oven, the second time right now is the Edge Kit. And as soon as we had prototype of the edge kit here, everyone was like, okay, right now we have 20% have
Mm.
done on the whole
Yeah.
product development
Right, right.
process here.
Yeah.
And this was one thing, if you had asked me this 2019 or 2020 maybe, I wouldn't say that the prototype. So from my perspective, the prototype is close enough to the
Mhm.
product, so we could launch that really fast. But to be honest, this process to have the prototype is a really early
Yeah.
stage process, and all the another processes like certification, going to production, talking to manufacturers,
Mhm.
everything, they taking a lot of time, and it's a huge amount of work
Mhm.
from prototype to the product and to the
Yeah.
market.
I've actually thought about, discounting my consulting services for prototype versus production, because the prototype is the fun part, like it's not
Mhm.
easy, but it is the fun part, right? It's like, oh yeah,
Mhm.
buying one of these, I don't, I could design with this on DigiKey or Mauser or whatever supplier, doesn't matter. I can, cobble stuff together with Amazon and whatever, and it's just like, that's not that's not the hassle part, right? It's hard, it's just not the hassle. The hassle is all in
Mhm.
manufacturing is such a grind. So I think
Mhm.
you're right. 20% is a good estimate, I think, of the overall effort. Especially, like, I think what's interesting is, like, a less complex product. I think it actually shrinks that down, right? So, like, making a you guys make very complex products, I think. And so if you were making a simpler product, like you know, say just like it was just a breakout dev board type of thing, and it was just, you were just adding a single LED to a Jetson Nano, right? It's that sort of crazy
Yeah.
example.
Mhm.
That would then be what, 2% of the product, and then the rest would be like all of the other things to make that happen and get out in the world.
Absolutely. Yeah. I also think so that this could also be or will also be one major part how complex your product is to going to 50% by prototype or to 2% on that scale.
Yeah. Well, and speaking of complexity, let's switch over to your first product, which is what we teased here.
Mhm.
That is the Vapor Phase One. So this is a crowd supply campaign that started. It funded on the September of 2020. So that's been around for a
Mhm.
while, and it is built. It's out there. What is the so first off, what is it? I guess.
Yeah. So the Vaporphase one is an open source Vaporphase oven. How a Vaporphase oven works, it's a reflow oven for electronics, for smaller hardware engineering offices out there. What it is exactly that is that we have a heater and or in general you have a heater and a liquid. It's called Galden, and the Galden is boiling exactly at 230 degrees. And if it's boiling, it generates vapor, which is heavier than air. This means you have a 230 degree or and perfectly 230-degree vapor, which is perfectly for soldering electronics and prototypes out there, because you can be sure that all your BGAs, working after that, all you and all FPGAs, for example, don't kill your parts on your electronics. This is the USP at the vapor phase soldering process in general, because it's really defined temperature curve there, what you
Yeah.
have there.
So I remember I had never heard of vapor phase prior to Jonathan Hirschman, who used to run PCB NG. He was on the show back in God, what year was this? This was 2016. So I had never heard of it prior to that. It's been around a long
Mhm.
time, I think, but yeah, I never heard of it. And they did it because I remember they were doing like kind of low run prototypes as well, like but manufacturing, maybe up to 100
Mhm.
sort of thing. And yeah, it's just mind blowing to me, like how that works. It's like basically giving your components in solder paste a bath in like 230-degree,
Yeah.
quote unquote water, but not water, vapor.
Absolutely, yeah, in 230 degrees, hot
Yeah,
clouds,
yeah,
and they but it's really gentle for the
yeah.
electronics, at this point, and it's really nice
Well, I feel
because
like the alternative is the important comparison there. I think about like my piece of crap infrared oven, right? It's basically like a literal toaster. And what I'm relying on there is two things.
Mhm.
One is radiation, like direct radiation off the elements, but really that it's heating up the air and the air is circulating and that I get uniformity of that air across all the components as well, which is not normally the case. Usually it's more
Yeah.
uh, non-uniform. Bad. It's bad.
Mm. And I mean, also, if you have, for example, higher components or something like this, your infrared energy don't comes to the part which has to be soldered, for example, because it's hidden by a large component which is before that.
Oh
So
yeah,
you have some solder problems with infrared, for
yeah. What are they?
example.
There's that shading, or what is that called? There's like
Mhm.
a manufacturing thing they talk about.
Yeah, it. I would also call it
Uh huh.
shading. So yeah, this also leads to some problems. And we had, for example, the problem, we worked with hot air gun, and yeah, basically it's desert. It's a desert air 400 degrees gun
Wow.
where how we soldered our PCBs
Uh huh.
back then, and we had the problem in our prototypes that yes, some of the prototypes in this engineering processes yeah, were destroyed because of the
Mm-hmm.
soldering
Yep.
process we had with the
Mm-hmm.
hot air gun. And nothing is more frustrating than being a creative person. Like we said before, prototyping is the or to the prototype, it's the
That's the fun
fun
part. Yeah,
part at this
yeah.
point. But yeah, but not the fun part is to assemble pick and place your components by hand for
That's
five
right.
hours, for example, or 6 hours. And then your prototype isn't working because of a
Mm-hmm.
soldering issue
Yep.
at this point. And we had this problem for a prototype at our desk, and this was really really frustrating. And so we are searching for some solutions which are a really gentle solder process at this moment, because at this point we thought, okay, what we could do to improve our work, what we could do to focus on the
Mm-hmm.
fun part in prototyping, which also yeah, helps us for the prototyping, for
Yeah.
example. Yeah, so we choose that we need definitely a vapor phase oven, and we took a look at the market. And yeah, unfortunately, as a startup, we take a look to the equipment, which is really expensive. So vapor phase ovens are really expensive, and we take a look to the market back in 2019, I think, and we didn't find a solution that could fit our quality expectations and also our
Yeah.
pocket.
Right.
This
What
is
and
why
what were the relative prices
this is
of the available stuff in the marketplace?
so it's over 10,000 euros, I
Mm-hmm.
would say,
Okay.
in general. What a vapor phase oven costs, and yeah, I would say also 500 euros for some equipment where or are really a really tough invest for us at this point. And yeah, so it was completely out of scope. So we said, okay, let's go to the basics. Why we don't build our vapor or a vapor phase oven
Mm-hmm.
for ourselves at this point? Because yeah, the physics behind that isn't that hard, to be honest, because it's a heater and it's a liquid.
Yeah.
So for the completely
I
general
remember
thing.
seeing I remember seeing I think there was a Hackaday project or something like it where someone was doing this kind of ad hoc. They were just doing their own thing. And they were just basically using a heater to
Mhm.
heat up And I remember distinctly thinking like, I don't do that. I don't just heat up. I don't I don't heat up random liquids, even if they are known. And then like I assume somewhat noxious, or maybe not noxious so much as just
Mhm.
not safe to breathe in.
Mhm.
But it does seem like it's relatively simple in that way. So why I guess maybe a good
Yeah.
question is why doesn't this exist in China right now? Like why can't I buy one of these from China?
So I think this will come, but also if I think this technology isn't that common in the market, and not that many hardware
Hmm.
engineers know that, because, like you said, also if you're doing it by yourself, so have a heater and a liquid and everything, this isn't 100% safe, to be honest, if you don't treat it
Yeah.
correctly. So it's getting this liquid. It's getting toxic if you heat it up to 300 degrees, something like
Oh,
this,
interesting.
290.
Okay. So precise control is important, right? It's not like you don't just like light a little
Yeah,
Bunsen burner beneath it and be like, oh, well, it'll be fine. It's not like self-regulating in that way, right?
yeah, absolutely. So don't
Uh
try
huh.
this at
Yeah.
home at this point. But you have to regulate it really precisely, and don't put that much power into some defined surface at this point. So this is really important, and yeah, that's why I think it's also not came that much to different industries, and not requested that much by different hardware
Hmm.
engineers in the past. But right now, if we are talking about to have smaller components, have also heavier components on a smaller place, for example. This are challenges for normal infrared reflow processes or hot air reflow processes at this point. So this is where the vapor phase maybe also became more popular in industries for electronic development, for example, and also for more or faster prototype cycles at this point. It's also important that maybe you have your really good reflow station at
Hmm.
home, or
Yeah.
in the office or something like this. And so also at this point, we think that prototyping will become more and more popular because of the innovation cycles. They're getting shorter and shorter
Yeah.
every time and
Yeah.
every year.
Yeah. Yeah. That's great. And so, well, tell people like what. So can they buy this right now? So it was a crowdfunding thing. Is it commercially available? How do they get a hold of one?
Mhm. You can buy one if you want
Uh-huh.
one, to be
Yep.
honest,
Uh-huh.
at
Yep.
this point, over our web shop, and also over different distributors. So coming back to the business side at this point, we are working with a lot of distributors
Hmm.
around the world. So, for example, with Mouse Electronics for the US, and for the Europe, we're working with right now 4 different distributors for different
Hmm.
countries, and these are the only 2 areas we are sold the system or selling the system right now, because of different
Yep.
certifications we
Yeah.
need. And to be honest, to get certifications for the US was one of the toughest
Yeah.
challenge in the history of PCB
I saw
arts.
that on your it was in the updates on your crowd supply page. So it didn't look like it was easy.
Yeah, it was really hard, but but it was also
What about it? Because it was it because of the chemicals, or was it just more about like FCC and CE type stuff?
more about that one machine is going to sell to the
Hmm.
US, and from a German perspective, this is horrible for all the authorities which need to
Ah.
check that. We're working with different certification authorities here in Germany, which are certified for the US, and that's just
Hmm.
2. Yeah, so they were really pricey, and they're really looking into each detail,
Mm.
so for machine safety and everything. So yes, of course, that's their job, but I think the certification took about four
Oh my god.
weeks, so close to
Uh-huh.
full time, that someone looked into documents, reviewed everything, and they tried to find something what maybe could damage some other parts or something like this. Yeah, it was really heavy to make a
Yeah.
certification there for the US. For Europe, it's quite easy. So for Europe, it's really easy, to be honest, compared to US.
I mean, that's great. That is not normally the story. No, people aren't normally like, oh, Europe regulations are so easy versus the U.S. Usually, it's the other way around, and so that's good. good for, selling to Europe. That's great.
Definitely. So I also think it's easier for US based companies to launch products in the US
Ah, okay.
because the certifications are more easier to get. But from a German or European perspective, it's
I see.
really heavy to get this market barrier
Mhm.
also, which is between Europe and the US. But I honestly don't know if you're working in the US and launch products to Europe, if it's also
Got it.
that hard. So maybe it is. I don't know.
Yeah, right, exactly, yeah. Well, we should mention, so the price tag is not cheap, but it is still half of what you said otherwise, right? So you said it was 10K
Mhm.
euros to get any other machine. So it's 5,000 euros for the current
Mhm.
machine, which is, I think, you think
Yeah.
about, like, yes, it's I think I paid like 300 bucks for my cheapo oven, but you think about how many prototypes I've potentially destroyed, and it starts to add up pretty fast. And I think about the other thing too is, like,
Yeah,
the ones
definitely.
that you're targeting, like you mentioned with like BGAs. Increasingly, people are working on very high end prototypes local to their, in their local shop,
Mhm.
where they might have exported those to a assembly house previously, and it actually is kind of possible to do this stuff in house now. So you start to save money there too.
Absolutely, yeah. And I think it's getting more popular and popular to have the more complex prototypes on a desk at home or at office or locally, and don't work with your manufacturer for single prototypes
Hmm.
at this
Yeah,
point. So we also want to enable people and hardware engineers out there for faster innovation cycles at
yeah.
this point. And yeah, it's not cheap. So we also don't wanted to have this price point, to be
Hmm.
honest, because 5K is also really expensive at this point. Our first idea was to help other makers and hobbyists at this point for have a solution at their home, at their desk, for example, for around $1,500. That was our main goal at this point. To be honest, we had some features in the system which weren't allowed or which don't allow us to have this price point
Yeah.
at this point because, for example, we have a adjustable lift to have a really precise definition of the temperature curves and the
Mhm.
profile temperature profiles you want to give in to have a really good solder result for your prototypes. We are water cooled within a fixed connection, and we have some of really good features for prototyping from our point of view, and have a really good stainless steel enclosure and everything like this. So the quality for the product was one of the main point, but also so one of the main point why we can't reach the $1,500 at this point, but also
Yeah, totally.
the certifications for
I
the
mean,
US.
I also feel like if, you're targeting a 1,500, say you were looking at the maker market, right? But like 1,500 is kind
Mhm.
of outs I feel like that's outside the, with if you're outside a certain realm anyways, you really start to limit how many people in that market anyway. So, so now it's like, okay, now you're
Yeah.
up into prosumer, or maybe actually pro, in terms of like that sort of thing. And at that price, at that point, I feel like the price becomes, it's not an issue, but it's really, then it's a true comparison in the marketplace, and like what else is out there. So then it just
Mhm.
becomes a discussion of like, well, this is the best process. Now, look at all the things. So, like, if I've convinced you that vapor phase is the best way to make your prototypes on your desk for your professional exploits and the things that you want to do in your home lab, okay, I've convinced you of that. Now let's look at the marketplace, and this is the cheapest, best thing in there. It's like, then that's an easy sale, I feel like. So it's just really, it's almost like you have to be like an evangelist for vapor phase in the home office, or small office.
Mhm.
In the well ventilated small office.
Yeah, it's okay. So we don't lost that much of the garden, so it also don't need that good ventilation. But I get the
Yeah,
point
yeah, yeah.
absolutely.
Yeah,
Yeah.
I mean, so, I mean, do you give guidance on that? I mean, should this be have a vent hood or anything like that, or is it okay to just do an open air?
Yeah, so we recommend, for example, to have a window near of the
Mhm.
machine, for example, because it smells a little bit. So the garden, if it vaporizes, it smells a little bit,
How do you spell
like
that? The you're talking about the liquid that becomes the vapor, right? How do you spell that word?
yes, of course, Galden.
How do you spell it? Letters, like letters wise?
Sorry. So GALDEM.
GALD. Okay.
Yeah, it's the this liquid from Solvay
Uh-huh.
from the US, and they're the only company who produces this liquid,
Oh,
which is
yeah.
perfectly for the soldering. But also they have the monopole on this, and it's not the
Uh-huh.
cheapest liquid, so it's quite expensive. So we are talking about 1 kilogram. So this is what the
Uh-huh.
vapor phase needs, is around $200 right now. But this liquid, I would say we are right now soldering with 1 kilogram since one and a
Oh,
half
wow.
years.
Okay.
So yeah, about 100 or 200 different
Yeah.
solder cycles. So it's an investment which you don't
Right,
need
right.
to
It's not
refill
like
that
a
often.
spool of filament on your 3D printer that'll run out in a day or two if you're doing some printing. Yeah.
Yeah,
Yeah.
yeah,
Interesting.
absolutely.
Yeah, so I had never heard of this stuff before. I'm looking at so it is a perfluoro wait, where was it? Perfluoro, it's a PFPE. Oh, my bad
Hmm.
chemistry days are coming back. Perfluoro, but it is inert, it says. So that's interesting, right there, that it
Yeah.
is listed as chemically inert. So basically, it's designed for this sort of thing. It's basically made as a temperature stability type of thing. And it says even that you can get it at different temperature. Boiling points range from 55 to 270 degrees C. That's super cool.
There are also different
Uh-huh.
liquids out there from Solvay, and yeah, they have different boiling temperatures and also supported by the vapor phase
Huh.
one. So if you have different solder pastes, for example, which have had another point to get liquid at this point,
Huh.
you also could take other liquids from Solvay
Yeah.
here.
That's so another one they have, another product they have. This is I've never heard of this stuff before. This is super cool. It says Galden D is the electronics testing suitable for electronics reliability testing, including thermal shock resistance and hermetic sealing. Huh. So you
Hmm.
could you use the Vapor Phase 1 machine to actually as like a ad hoc tester of like thermal shock and things like that? Like if you had other monitoring on there?
Yeah, we never had this request before, but I also didn't thought about that. But we could do really fast increasing temperature
Uh-huh.
profiles with different
Uh-huh.
temperatures. So this also could be possible at this point. That, for example, if you're using Galden 160 or
Yeah,
something
yeah.
like this, you could also make a shock test with it.
Okay, well, I will send you my bank
That's
account, and
interesting.
you just send me when people start buying for
Yes.
that application. You just give me the standard 50% cut. That's fine, like per use. Yeah.
Definitely,
Okay,
yeah.
that's cool. No,
With the code
this is
Chris20.
like better living through chemistry sort of thing, man. That's really interesting. This is like why we have chemists. Here we go. Polyether fluorinated fluids. Wow. And so they're the only people that make it. Is that right?
Yeah, sure. I think they have a patent on that, so
Uh
they
huh.
also could have a really high price point on this liquid.
Uh huh.
But to be honest, the cycle costs are around so for one soldering about 50 cents.
Uh huh.
So it's okay
Yeah, that's not
from
bad at all.
our point of
Yeah.
view because yeah, you get really good soldering results out of that.
Mm.
And yeah, we never soldered ever again with a hot air station
Mm-hmm.
since we have the vapor phase at this point.
So so it doesn't collect. I guess the flux that's in solder paste as well. That normally vaporizes and kind of burns off. Does that also burn off out of the liquid as well? Like
Mhm.
so the vapor comes up over top of the board. The solder paste is holding the little balls of solder in place. Does the solder paste flux, does that get into the actual Galden, or does that just kind of burn off?
Yeah, so it drops sometimes into the Galden reservoir, which is under the
Hmm.
PCB at the vapor phase. So after a time, you have a milky liquid beneath that. So this is the mix between the Galden and the solder flux. But this is also really easy to clean at this point.
Yeah, like because it separates out and that sort of thing.
Hmm.
Okay, that's great. Huh.
Yeah, so you don't burn it at this point, and yeah, you don't have this yellowish things on your PCB that
Yeah.
much anymore.
Yeah.
So
Interesting. So and then so so I'm just kind of visualizing, painting a little word picture here. So basically the reservoir is underneath the PCB. it gets heated up. The vapor phase kind of
Mhm.
like climbs up above the PCB. It's kind of like creeping up, like water, kind of like a water rising sort of thing over top of the PCB. And
Exactly.
then
Mhm.
as the process is finished, does the vapor stay around? I mean, like, how do you ensure that all of it has kind of slid off the board? Is there any kind of post cleaning process or anything like that?
So in general, yeah, the vapor is climbing up for the process to a certain point, and at this point, we have installed a water pipe and a water cooling, which lets there that the vapor phase is breaks on a certain point of height. So we could regulate the temperature over the height of the lift at this point, so to ensure all different solder profiles for the PCB or for different electronic parts on it. At this point, the normal profiles, the soldering profile is yeah, if they are finished, we try to take the PCB to 120
Hmm.
degrees Celsius. This is where the Galden slowly vaporizes at this point. So you get a dry PCB out of the process at this
Ah,
point. So if you want, so 120 degrees holding your PCB after the process for 10 or 5 minutes. This is the clean process. So this will clean all the Galden from the components and below the components, for example. To get a dry
yeah,
PCB out of the vapor phase at this point. We call this the anti-condensation mode.
yeah. Right, because I would imagine that, like, even though it's an inert thing, I wouldn't necessarily want to have like little droplets in between BGA balls, just from a reliability standpoint. Even
Yeah.
if it's non-conductive, it's fine. But like, yeah, I just would want it to be to ensure that it comes out of there.
Yeah, so we also wanted yeah, dry
Yeah.
PCBs because it's not it doesn't look natural
Uh-huh.
if you look at a PCB
Yeah,
which is
yeah,
wet
yeah,
and then put it to the electricity or
yeah.
something like this.
Right.
That's not good.
Huh. Well, that is really cool. So okay, so you buy a unit, you have it near a window, maybe a little passive airflow away from it, just to get rid of the smell. That's great, huh?
Mhm.
And then control wise, all the so just looking at the promo videos and stuff like that, it's controlled using a little screen. It's got like a controller board, much like a lot of the infrared reflows are, but a little bit fancier. It looks like.
Yeah, we also wanted to design a machine which is
Hmm.
looking good, which is also making fun
Yeah.
to interact with. That's why we decided to choose yeah, a 4-inch capacity display to interact
Yeah.
with the
And
machine, to see also live profiles and
yeah,
everything. Yeah.
it does look very nice. That's great.
So thanks.
I was going through your blog and I realized the first time I saw PCB art stuff was when you guys were posting about the rendering of PCBs because you put a Xilinx zinc onto a
Mhm.
feather form factor board, which is insane. Like the density of stuff going through there. I remember seeing that and being like, first off, the renders were amazing, and second off, the fact that you did that is insane.
Yeah, at this point, I have to say it's yeah, a private project from a
Uh-huh.
coworker from
Uh-huh.
Lucas at this point, and yeah, he's crazy about that. So he said, okay, I want to do this project right now, and he's also yeah, rendering
Uh-huh.
this stuff, making this yeah, for marketing reasons really nice. And we said, because we also got many requests, so okay, could you maybe explain how the blender process is, and how the rendering process of our PCBs is going, because we are working a lot of with open source tools at this point. So we said, okay, let's make a quick tutorial about it, which you could find on our
Hmm.
blog.
Yep.
It's separated into 3 parts, and we try to, yeah, help other people to also have a nice renderings of their PCBs, because also if you have a prototype, they're just 20% from the product. You also have a marketing
Hmm.
piece, which is also, yeah, a lot of work at this
Yeah.
point, and this is also maybe one thing we could help other
Yeah,
engineers
no,
out there.
it's great. So Greg Davil, who's been on the show a couple times, he's obviously did a lot of that rendering type stuff, and we see this. I mean, whenever I see it on Twitter, it's instant eye candy. So it like you said, it is really good marketing, and it just kind of you're like, wait, is that real? No, that's not real. Oh my god, that's not real. That's so crazy. So yeah, and Blender has its own challenges. So yeah, helping engineers with Blender is very nice. That's a good thing.
Yeah, absolutely. And I mean, yeah, maybe we could see more eye
Hmm.
candies out there
Yeah,
in the future, but that is the hope of this
yeah.
tutorial and of our GitHub
That's
repository at
great.
this point.
Actually, this is a really good example. So I'm, just scrolling down the page here, and the
Mhm.
so like you have a close up of the featherboard, and it's got these 0201, maybe even smaller than that, but basically in and amongst the huge connector, the huge 2 millimeter JST, huge relative, a huge USB C connector. But like this is a really good example of like the where the vapor phase would help to get in there. You have all these tiny BGAs, and there would be a lot of shading in there as well, and that would really help in this scenario. It feels like.
Absolutely. And I mean, for example, the zinc feather, if you have a problem there, which is related to soldering or something like this, if you have, yeah, two boards connected under a BJA or something like this, you won't be happy for
Oh my
debugging at
god!
this
I just
point.
throw the whole thing away.
So,
Be like, "Yep, that was $2,000. That's going in the
yeah,
trash." Yeah,
and I'm
yeah.
done.
Just no thanks.
Yeah, and you have no chance to debugging this correctly. So with the vapor phase, it's a forgivable process at this point, because if your solder paste process wasn't that good, for example, at this point, the vapor phase could fix a little bit out of it. So not everything. It's not a magical
Mhm.
thing that will fix all your electronics, but it's a forgivable process. And don't yeah if you have to make a mistake in the process before, for example, a placement or something
Mhm.
like this, other reflow processes are not that forgivable like the vapor
Yeah,
phase at this
yeah. No,
point.
that's great. Well, this is really cool. Are you going to be continuing to like? Is it kind of like a one and done? Is it like, well, now we have it in stock and people can buy it if they want to, or are there future improvements that you're hoping to do for the vapor phase as well?
So in general, we are doing software improvements all the time. So new software features will come out for the vapor phase. For example, also more stability in the soldering process at this point. Also, yeah, some minor bug fixes and everything. So we are working mainly on the software side at this point, and for the product and hardware side of the vapor phase, for example, we are also working for, yeah, nicer PCB holder for double-sided PCBs, for
Oh yeah,
example, that
yeah.
you could, yeah, mount them easily in the vapor phase. And so some useful stuff for the vapor phase process
Mhm.
in general, which we are also launching maybe also
Oh,
this
great.
year.
Yeah, yeah. That's a good point. Like work holding is important. What's the relative
Yeah.
size so people know that like what's the biggest PCB people can put in there?
So at this point, we have a really small vapor phase,
Uh,
to be honest, because we're also focusing on our PCBs we had back there
mhm.
at this time. And so we are talking about 20 centimeters by 19 centimeters, which fits into the vapor
Mhm.
phase one.
That's 8 inches by 8 inches for all the U.S. dummies like me.
Thanks a lot. I wanted to ask if you could if you could
Can you
calculate
put
that,
that into
because
American,
yeah.
please? Yeah, yeah. Honestly, the thing that helps me with that, if I got that, did I get that right? I think I got it right. Yeah, I think I got it right. Right? I think I did.
Okay.
Is the thing that my reference point for all that stuff is 12 inches is a 300 millimeter wafer from my semiconductor days, and then you can kind
Mhm.
of divide by whatever you need it to be. So 200 versus 300 millimeter,
Okay.
200 millimeters is 8 inches. So
Yeah, okay. Divided by 2.54, right?
yeah, yeah, I wouldn't do that math, but yeah,
Quick
exactly.
maths.
Yeah. It's roughly 8 inches, I should say. Yeah.
Okay. Yeah, so we got a lot of feedback for this point, for example, that it's maybe too small for different PCBs, and we also saw that. So we are working right now maybe on a vapor
Hmm.
phase two.
Cool.
Yeah, but yeah, it's just in really early stage right
Hmm.
now. So, but this is also one point we are maybe working on
Okay.
in the
All
future.
right. Cool. Yeah, it's good to have the one in the title too, because then it's like, oh, maybe there will be a sequel.
Yeah,
That's great.
definitely.
So, will you be at the upcoming Embedded World? I know that you guys are based. You're based in Fürth. Is that? Am I? How's my German? Is it terrible?
It's beautiful. No, it's completely okay. Yeah, we're based in Fürth, we're just next to Nuremberg.
Right. So
Yeah.
that's where the Embedded World is, and that's coming up in March, I believe. So
Hmm.
I will see you there hopefully in March.
Definitely. So we will be there. We also have a booth at this point, which will be a little bit more fancier than the
Mm.
last time, because it was really, really
Yeah.
simple booth. I
Yeah,
would say the last
the
time.
startup area, they expect that you're just kind of showing up and hoping people look
Yeah.
at the product and not the booth. So yeah, it's a tough thing there. Yeah.
Definitely, yeah. But it's focused on communications, I would say, last time.
Yeah.
Will also be in the next
Yeah.
time with the Edge kit also and with the Vapor Phase at this point. So we will prepare something for the upcoming embedded
Yeah, I
world.
mean, you
Yeah,
should have live demos. That would be my jam, Live demo, solder boards, it'd be great. Let people solder their own boards. I'm sure the conference
yeah,
organizers would love it. Yeah. You wanna
yeah,
bring what to
definitely.
do
So
what?
there's something with 200 degrees. So they solder
Yeah,
here.
yeah.
What? No, if you're in Germany and you're talking to organizers from different fairs and shows and talking to them and say, okay, we want to solder there with 230 degrees
Mhm.
liquids. Yeah, they the
Yeah.
Germans, the conservative
Uh-huh,
Germans.
yeah, yeah. Well,
They're not
maybe you could
amused
do it in the
about that.
parking lot?
So
Come out to our special roving
that
around
would be
van that
ideal.
can't be caught by the police.
So- I think that's the second idea I will take from
There you
this
go,
call,
there you go,
from this
yeah.
podcast
I
here.
think, there's always, like,
So,
sub-events as
what was
well.
your?
You could always maybe have it at, like, if there's, like, a meetup or something like that, bring it to the meetup, that sort of thing,
Mhm.
so.
Yeah, we're also working a lot with universities and makerspaces and
Mhm.
fab labs
Oh,
here
cool.
in Germany. So they are also organized some meetups and everything. So we are also doing live demos there or in our office. So I mean, yeah, in Fürth,
Yeah,
that's
not too far away,
like we
huh?
said, next to
Yeah.
Nuremberg.
Short train ride, I'm sure.
Yeah, we also could do the live, yeah, the live shows
Great,
there.
great, yeah. There you go, just have, like, the after party at the PCB Arts, office, and then, crack a couple beers, solder some boards, it's always a good time. It's always a good time.
Definitely. So we will
Okay,
plan that
great.
for sure.
Well, I'm looking forward to seeing March Saber. Where can people find all this stuff and buy either a Vapor Phase 1 or an Edge kit?
You could find that stuff on our webpage, so pcb-arts.com. Yeah, that's where also our web shop is linked in, and also over LinkedIn you could also find us. And yeah, if you have some questions or something like this, just write me over LinkedIn. I will respond to that. And yeah,
Awesome.
at this point, I also would say I would love to see everyone at the Embedded World next year,
Yeah.
so in March. And yeah, if you want to come to the office after party, then so we will
Okay.
organize
All right.
that.
That sounds great. All right. Well, thanks so much for telling us about this stuff today, and we'll look forward to seeing more Vapor Phase stuff in the future.
It was my pleasure. Thanks a lot.